For the last decade, Bitcoin's proof-of-work system has run without disruption. In a proof-of-work scheme, Bitcoin miners compete to solve a cryptographic puzzle associated with a block of transactions. Every 10 minutes, all the Bitcoin miner nodes race to be the first to solve a block of transactions. Only one miner wins each block, meaning the other node's time was ultimately wasted. There's also a massive expense of electricity. Bitcoin is a system with low transaction throughput. It's about 7 transactions per second. And computer scientists have wondered, is there an alternative way of doing consensus? What if we took all of the wasted compute power from proof of work and allocated it in a way that makes transactions get processed faster? Unfortunately, Bitcoin's governance tends to be extremely conservative, so we can't run this experiment on Bitcoin. A change to the consensus mechanism probably won't happen anytime soon in Bitcoin, unless you count Lightning Network and sidechains. Ethereum's consensus mechanism is modeled after that of Bitcoin. It's proof-of-work mining. But Ethereum's governance ethos is quite different. Ethereum is in the process of planning and implementing proof-of-stake, which is an alternative consensus mechanism in which trusted validators are chosen to validate blocks of transactions. Subhan Nadeem is a student at the University of Waterloo where he studies computer science and business, and he's the author of several popular articles on Medium that explain blockchain concepts. He joins the show to talk about crypto from the point of view of a student, and he also gives us a great and thorough walkthrough of some different consensus mechanisms. If you like our series about cryptocurrencies, you can find all our old episodes by checking out our apps in the iOS or Android App Store, and they have all 700 of our episodes. We've got recommendations, related links, and discussions, and more. And it's all open source. If you're looking for an open source project to contribute to, we'd love to get your help. You can go to github.com/softwareengineeringdaily. We welcome all kinds of contributors, new developers and experts and engineers, as well as non-technical people. Like if you're in marketing or sales or design, actually those are technical roles, so I should specify this more specifically, but it's an open source project where we aren't just looking for engineers. We love all kinds of comers. So if you're interested in getting involved in the SE Daily open source project, we would love to have your involvement. With that said, let's get to this episode. Users have come to expect real time. They crave alerts that their payment is received. They crave little cars zooming around on the map. They crave locking their doors at home when they're not at home. There's no need to reinvent the wheel when it comes to making your app real time. PubNub makes it simple, enabling you to build immersive and interactive experiences on the web, on mobile phones, embedded into hardware, and any other device connected to the internet. With powerful APIs and a robust global infrastructure, you can stream geolocation data, you can send chat messages, you can turn on sprinklers, or you can rock your baby's crib when they start crying. PubNub literally powers IoT cribs. 70 SDKs for web, mobile, IoT, and more means that you can start streaming data in real time without a ton of compatibility headaches. And no need to build your own SDKs from scratch. And lastly, PubNub includes a ton of other real-time features beyond real-time messaging, like presence for online or offline detection, and access manager to thwart trolls and hackers. Go to pubnub.com/sedaily to get started. They offer a generous sandbox tier that's free forever until your app takes off, that is. pubnub.com/sedaily. That's pubnub.com/sedaily. Thank you, PubNub, for being a sponsor of Software Engineering Daily. Subhan Nadeem, you are a student at the University of Waterloo. You're studying computer science and business. Welcome to Software Engineering Daily.
Thank you very much for having me, Jeff. I'm a huge fan. I've been listening for a while, and I'm very glad to be here.
Well, that's great to hear. I'm a fan of your Medium work, so the respect is mutual. I want to start off with some basic questions about kind of who you are and your circumstances, because I'm doing this month of shows about cryptocurrencies and related technologies, And I'm trying to get an understanding not just of the technology, but the community and who is adopting it, who is paying attention, why they're paying attention, the different motivations of people. So let me just ask you, as a student, what's your perspective on the question of why engineers should look closely at cryptocurrencies?
Absolutely. That's actually a really good question because, so like you mentioned, I go to the University of Waterloo, and my interest in blockchain technology and Bitcoin technology actually stems from the environment in which, I study in. So about 6 months ago, when everything started to get into a frenzy, blockchain technology was the buzzword, and it still is. And especially in Waterloo, which is kind of described as the Silicon Valley of Canada, things started to really take off. They started buzzing about blockchain technology. Companies started popping up everywhere. And what's happening now is that it's turned into this industry ripe for opportunity. And everywhere you look, you're seeing blockchain technologies pop up. You're seeing blockchain researchers, blockchain learners, educators pop up. And really, I think what's important to realize for anybody looking to get into this field or trying to realize the value in this field is that this technology itself, blockchain, Bitcoin, Ethereum, all of these platforms, they're largely untapped. We're almost 10 years in, but the true potential of all of these have not been realized. And to really understand why that is, you kind of really have to get into the nitty-gritty and the fundamentals of the technology. And that's kind of where I started myself when I got into trying to realize the potential of this technology. I told myself, you can't really understand what's going on here without understanding the fundamentals. And so it's a tough question to answer without explaining, why this technology is as valuable as it is. But that hype is not unwarranted, and it's existed, for the last year or so, and it's going to keep going.
Right. And this is one of the reasons that led me to eventually deciding I really needed to dive deep into it, was to do anything short of a dive into the fundamentals is to honestly do a disservice to yourself as an engineer, because it's really hard to understand the significance of the technology without really diving in and understanding the bigger picture and seeing everything. And you risk ending up as a victim of some soundbite like, oh, I'm excited about the blockchain, but not Bitcoin, which just does not make any sense. I mean, it makes sense in the sense that private blockchains kind of are cool, I guess, in the sense that you could have a centralized but partially exposed ledger. But really the meat of what makes this stuff important is what is at the extremes of the technology, the extremes of the decentralization. Even if that's not what ends up being what is most widely used or what is most widely impactful, just seeing the extreme end of it is really the only way to understand the potential of it, from my point of view at least.
Absolutely, I agree. Two things that always come up in common conversation is, one, nobody really understands what Bitcoin is. Everybody talks about it. And I see that as a challenge to myself. I mean, I'm only a student. I'm still in school. But hey, I mean, if I can spend a couple of months researching it and understand the fundamentals of the technology, I feel like anybody can and should be doing so without kind of jumping onto the bandwagon, like you said, talking about private blockchains, and yet not realizing the true kind of proof of concept that came to life with Bitcoin and how it's being moved forward with platforms such as Ethereum and other platforms such as private blockchains as well. And so truly understanding how private and public key cryptography, one-way hashing, and as well as the distributed ledger system that involves blockchain technology, how all of these systems come together without realizing that, I feel like it's very difficult to really have an intelligent or even a halfway educated conversation about this technology.
Yeah. How do you allocate your time between studying cryptocurrencies versus other classes? Or are there classes at Waterloo now where they are teaching this stuff?
No, so at Waterloo, there is, as far as I know, no such focus on blockchain technologies. I remember reading a little bit. Some colleges are introducing courses in cryptocurrency, which is pretty cool to see. For me personally, the reason why blockchain is intriguing is, first, there's this whole entrepreneur side of it. There are companies popping up left and right, trying to incorporate blockchain into anything that they can get their hands on, any company they can get their hands on. MongoDB has come out with their own enterprise blockchain, for example, which is insane. I have no idea how that works. And so that's just one example of how all of this is kind of revving up in the entrepreneurial world. And so that's kind of where my interest stems from, this entrepreneur side of things. And so back in the summer, I saw all these companies popping up. I was like, hey, I got to hop onto this bandwagon because I like coming up with these ideas, and the potential to start a business is very appealing to me, even as a student. But then I took a step back and I realized, hey, it would be a lot better for me to understand how this technology works as an engineer, because then I can work on building these solutions and working on top of these solutions in the future by having a fundamental understanding of it. And so for me, really, it's just prioritizing what I want out of my career in the future. And that's really to build a solution. And I have a fundamental understanding of a solution that can disrupt something meaningful way, in a meaningful manner. And so that's kind of where this interest of taking a step back, looking at the fundamentals, looking at how the technical details of blockchain technology work. And anybody out there, I think, should do the same if they're really, really interested in delving into this technology.
Well, in contrast to the approach of trying to start a business today, or perhaps trying to mold some semblance of a business solution into something that could ICO, I think the education approach is just much safer, because in the universe where these ICOs or these short-term businesses end up not blowing up or ending in jail time or SEC fines or getting hunted down by your token holders, in the universe where those do not end up in catastrophe, that is some universe where cryptocurrencies and decentralized technology has really taken hold in a meaningful way, as opposed to a thought experimental way, which, to be clear, we're pretty much still in the thought experiment phase. And if that universe holds true, then your investment in knowledge will probably lead you to opportunities that are going to be at least as financially profitable as the short-term ICO, short-term business that you might have started today would have been. So you're probably not even giving up anything by not not investing in cryptocurrencies themselves, even not buying Bitcoin or Ethereum, and instead spending your money on like Udemy courses or something, or like a gym membership is probably more worthwhile.
Absolutely. So that's actually another big reason why I believe education in this field is a lot more fundamental than, just bypassing that and trying to dive in and get your hands on an ICO or start building a token. I'm a skeptic when it comes to this field, and I feel like everybody should be a skeptic because, like you said, we're in a very thought experimental phase when it comes to this field. And there's a lot going out there that I don't understand, a lot of people don't understand, and frankly, every day there's something new that just keeps popping up that really, nobody really understands, but everybody's trying to monetize and capitalize upon. And so that's something that has to be looked at very, very carefully in this field. And so if you make an effort to really understand how this technology works, how it can be applied, the pros and cons of every single project that you may potentially want to look at, invest in, or build, if you can do that in an educated manner, then like you said, you have a far better chance of being profitable, of making an impact, of not ending up in handcuffs down the road. And that's really, really one of the most important things to realize in this field. If you don't really understand what's going on here, it's a very dangerous thing to get into because you could very easily get conned out of your money, build something that makes other people lose their money, or just break the law, break regulations upon you that you didn't intend and cause consequences that really won't be great for you. And so that's why I have a lot of colleagues that approach me and they tell me about new projects coming out. And every single one, I take a skeptical approach to it, and I take a very educated approach to it. Even Bitcoin itself, when everything started to click for me 6 or 7 months ago when it came to understanding the technology, I was a skeptic. I took my time, I understood the realized impact of this technology, and then from there I started to teach about it.
QCon AI is a software conference for full-stack developers looking to uncover the real-world patterns, practices, and use cases for applying artificial intelligence and machine learning in engineering. Come to QCon AI in San Francisco from April 9th to 11th, 2018, and see talks from companies like Instacart, Uber, Coinbase, and Stripe. These companies have built and deployed state-of-the-art machine learning models, and they've come to QCon to share their developments. The keynote of QCon AI is Matt Ranney, a senior staff engineer at Uber ATG, which is the autonomous driving unit at Uber. And he's an amazing speaker. He was on SE Daily in the past. And if you want a preview for what he is like, then you can check out that episode that I did in conversation with him. I've been to QCon 3 times myself, and it's a fantastic conference. What I love about QCon is the high bar for quality. Quality in terms of speakers, content, and peer sharing, as well as the food and the general atmosphere. QCon is one of my favorite conferences, and if you haven't been to a QCon before, make QCon AI your first. Register at qcon.ai and use promo code SEDaily for $100 off your ticket. That's qcon.ai, and you can use promo code SEDaily for $100 off. Thanks to QCon for being a sponsor of SE Daily, and check out qcon.ai to see a fantastic cutting-edge conference. It's funny because even the people who are teaching Bitcoin, like I just interviewed Joseph Benoa a few days ago, and he was one of the instructors for that really good series of videos that Princeton put out about cryptocurrencies, and he's one of the co-authors of that textbook that came out that was really good, but a really good textbook on Bitcoin. And he's skeptical that Bitcoin will even be here in 5 or 10 years. Like, here's a guy who is definitely in the top 0.1% of people in the world who understand these things, and has essentially given his entire intellectual horsepower towards understanding cryptocurrencies, and he's skeptical of the godfather of cryptocurrencies. He's skeptical of Bitcoin. So if there's a sign that this stuff is important from an intellectual pursuit, and perhaps maybe not from a present day financial market use case implementation pursuit, I mean, I take that as a pretty strong sign. But that said, I mean, you must have. I know how students think, and I know how, like, the minds of students can work at a frenetic pace such that something like day trading cryptocurrencies is actually something that a student, they have the mind to do it. That 17-year-old, 18-year-old mind. I know this because I used to play poker, and your mind is like attuned to being really good at things like video games and things that you can just have a feel for the market or a feel for the game. It's like the prime of your age. So and given that you go to Waterloo, you must be around some pretty sharp kids that are day trading, and they must be making millions. Like, are you having to quell some FOMO when you're talking to the day trader types?
Oh, yeah, absolutely. At my office, I work for a startup in Toronto called Fix. The average age here is, I think, 24, 25. Everybody's nuts for cryptocurrency. Conversations are happening daily. All of my friends are having conversations about cryptocurrency. You head over to Waterloo, there's hackathons happening based around Ethereum. For anybody who knows, CryptoKitties, the most popular Ethereum application in the world, it came out of Waterloo in a 36-hour hackathon. All of this is happening at an incredibly rapid pace. It's all around me. And you're right. You feel that FOMO. You feel, especially when it comes to investing your money, you feel, I want to dive into this. Everybody around me is making millions. I personally know a few people who have definitely made an insane amount of money that I would not have been able to realize. But I take that feeling and I invested into education. I do not like speculating on the price of any cryptocurrency assets just because of the inherent volatility that exists now, and it will probably exist for the near future and the far future. And so whenever somebody asks me, what do you think of this cryptocurrency? Should I invest? I tell them to instead look at the education, learn something about it, educate others about it. There's a lot more inherent value in that, and that will make you be able to understand this technology at a much better level in the future. And so at that point, you can make that decision for yourself. Is this technology valuable enough to make an impact? What are the cons of this technology? Will this technology ever go to zero? Could it ever go to zero? I know this because I've researched the technology behind it. And so at that point, I feel like you don't need to ask anybody. You can make that decision for yourself. And so that's really where I stand when it comes to all of this hype and buzz around me. I much rather try creating something of my own or researching the technology at another level rather than try to invest in something at this stage of the cryptocurrency like market at least.
Before the show, we were talking a bit about your article that you're writing right now, which is about proof of work versus proof of stake and some aspects of Bitcoin mining. And I'd like to dive into a technological discussion with you. So in order to warm people up for a proof of work versus proof of stake conversation, I believe most of the audience is, at this point, if they're tuning into this episode, they're probably at least reasonably familiar with how transactions are processed in Bitcoin. But maybe you could just give people a little bit of a stretching exercise, warm us up with how are transactions processed in Bitcoin?
Absolutely. So I own a Bitcoin. I want to send it to Jeff. What I do is I take my Bitcoin wallet and I send it to my nearest node or a node that I trust. And I say, take my one Bitcoin and give it to Jeff. This node propagates it all across the world until it gets to a miner. And actually, all miners will receive this transaction that I'm willing to execute. And so once a mining node or a miner receives this transaction, what they do is they conduct an algorithm called proof of work. And what proof of work, it is essentially a stake of a massive amount of electricity and time in order to verify that this transaction is in fact valid. And it's what it is at a very high level, it's a cryptographic puzzle. And once they solve this cryptographic puzzle, they publish this verified and cryptographically solved block and transaction block, which consists of my transactions and many others, to the rest of the network. And the rest of the network accepts this transaction as true, and they start building the next block upon it. And so that is essentially how the blockchain network operates and validates transactions. I hope that's a good high-level explanation to everybody out there.
That's great. And just to put a few more points on that might be relevant to our conversation. So if you're going to transfer a Bitcoin to me, you are issuing a transaction. The transaction is, I'm sending one Bitcoin to Jeff, and that's the data load that you're going to send to any Bitcoin full node in the network. And that transaction goes into that node's mempool, which is the in-memory set of transactions that have not been accepted by the network yet. And periodically, a Bitcoin full node is going to pull a set of transactions from that mempool into a block, and they're going to start to try to calculate the solution to a puzzle that turns that block into an acceptable set of transactions for the Bitcoin network. And if they successfully solve that cryptographic puzzle, then that means that they have proved that this block is acceptable to the network, and they will publish that block and its solution to the other full nodes so that the other full nodes can see, hey, somebody has a new block, which means that they have a longer chain of blocks than anybody else in the network. We need to accept this so that we can start working on a fresh set of transactions to include in a new block so that we can win the prize that's associated with the next block of transactions. And there can be some churn in there. If two people solve disjoint puzzles at the same time, then you can have, different blocks that get calculated and get accepted to the blockchain, which means that if I'm trying to verify that I got a Bitcoin from Subhan, then I may want to wait for 2 or 3 blocks or 6 blocks or however many blocks I need to feel comfortable before I say, okay, this transaction has been fully accepted by the network. It is very unlikely to be undone or to be double spent. Is that accurate information?
Absolutely, yeah. A lot more detailed than what I just said. And yeah, absolutely accurate. Just a quick distinction that I want to make. So you mentioned that there are full nodes that pull the transactions out of the mempool and attempt to calculate this proof of work algorithm in order to publish the block. What happens is that the majority of nodes that exist today are actually full non-mining nodes. And what these nodes do is they conduct economic transactions and they propagate blocks or transactions across the network. So you're right in the sense that each node has a mempool. This mempool holds almost every transaction out there, save for transactions that have too low of a fee to be accepted. And then these full non-mining nodes propagate the block or propagate these transactions to mining nodes that then pull them out of their own mempool and then start mining.
Okay, that's a good point. So, that said, what do people misunderstand about Bitcoin mining most frequently?
I think the biggest misunderstanding is its security. A lot of times, because it is very fundamental, it is a bit of a tricky concept to grasp. People underestimate the security of the network. And so, at a very high level or in very basic conversation, to this day, you still hear people say Bitcoin's insecure, it's a scam, et cetera, et cetera. And that's because the fundamental value of proof of work isn't realized. The fact that this algorithm has been able to secure the network in thousands and hundreds of thousands of transactions over 10 years is entirely ignored because the value of proof of work is not fully realized and fully understood. And so that's really where a lot of misunderstanding comes. Not so much these days. If you're into the blockchain technology field, everybody has realized, a lot of people have realized within the cryptocurrency field itself that proof of work is proven to be a reliable, fault-tolerant system when it comes to securing the blockchain. But outside of that community, there still is a lot of misunderstanding and a lot of educating that needs to be done about the security of it.
And just to give a little bit more color on the basics, explain the interaction between light clients, like a wallet, like a Bitcoin wallet that I have on my phone. What's the interaction between a light client and a full node?
Absolutely. So what a full node does is it communicates with other Bitcoin full nodes, and upon a fresh start, it downloads every single Bitcoin transaction on the blockchain from the very first day, downloads it from these other nodes, and then it begins to validate every transaction starting from day zero. So it builds its way up the blockchain, begins to validate the transactions, the inputs and outputs to each transaction, all the way until we get to the current and most recent block. So I believe currently the blockchain is about 150 gigabytes in size. So it will download all of that, start validating every single transaction until it gets to the most recent block. Then that full node is responsible for propagating new transactions and validating new blocks that it receives. And so a full node is, as you can imagine, a very intensive computer per se. It needs a fair bit of storage, a fair bit of bandwidth because it's propagating transactions and blocks to several other nodes on a 24-hour basis. And as well, it requires a large amount of storage for the blockchain itself. And so full nodes are not what you and I would use on a daily basis to transact with Bitcoin. You and I would use something called a light wallet, like you said. What a light wallet does is it downloads a summary of each block from the blockchain called the block header. And the block header is a easily verifiable hashed summary of each Bitcoin block. It's only 80 kilobytes large, approximately per block. And so what my light node can do is it can query my nearest full node, ask for that block header or for all of those block headers, verify that this chain is valid by hashing each block header. And upon doing so, it can then propagate new transactions to full nodes, which then send it around the network. So light nodes essentially act as user-friendly clients, or they're called SPV clients technically. And so they're really built for data use for Bitcoin.
And not to get too technical here, but I've been trying to figure out what is the best way to explain the importance of the Merkle tree in the interaction between light clients and full nodes. I've been trying to basically indicate to the listeners that the Merkle tree is a data structure that is worth inspecting without trying to explain what a Merkle tree is on the show, because I think it's hard to explain.
Absolutely, yeah.
But I would just say, for anybody that's interested in data structures, it is one of the coolest data structures, and I think I still don't have a good enough understanding of it to explain it and perhaps even to grasp the importance of it. But maybe you could explain at least, why is the Merkle tree such an important data structure? Why is it essentially key to how the Bitcoin network works and how it's actually usable?
So the way I like to describe a Merkle tree is that it's a summary. It's a verifiable summary of all of the transactions or all of its children that exist. So currently, Bitcoin transactions are stored in a Merkle tree. And the root of this Merkle tree is essentially a summary of every transaction that exists below it. So without having to download every single transaction and ensure that every single transaction is valid, as long as other nodes have accepted the root of a Merkle tree as valid, this root of the Merkle tree is just a few bytes long. All you have to do to ensure that the transaction set for any particular blockchain is valid is to just look at the root of the Merkle tree, compare it to other nodes' roots of the Merkle tree, and ensure that root is valid. And the reason why it's so important is because no matter how many transactions, you could have thousands, hundreds of thousands, millions of transactions within a tree. No matter how many transactions you have, all you really have to do is look at the root of this tree to say, hey, all of these transactions still exist within this tree. This, I believe, maybe 10 kilobyte long root verifies that these transactions exist, and so that's all I have to worry about. I'll download this block, accept it as valid, we're good to go. No issues in terms of validating every transaction from the bottom up. And so it really is just a verifiable summary of transactions that exist on the blockchain network.
And it's compact so that even if I'm running a light client on my phone that has the Merkle tree, that's all I need in order to verify that a certain transaction, that if I've got a light client and my light client is in a relationship with a full node and it's using that full node as the source of truth, and it's like, pinging that full node, or maybe it's pinging a couple full nodes and saying, hey, what's the state of the blockchain? Just give me the digest, give me the block headers, and I'll build my Merkle tree out of them, and I can verify whether transactions are legitimate or not, even though I do not have an entire full node myself. Did I get it right?
Yeah, so essentially all you really need is, for what a full node will do is they'll accept the entire set of transactions in a new block, and they'll go through every single transaction and they'll say, hey, this transaction is valid because Subhan previously did own a Bitcoin. He's sending it to Jeff, and we'll say Jeff has a Bitcoin. And it's a little bit of a caveat, but it's interesting because every transaction in a Bitcoin on the Bitcoin network is essentially routing Bitcoins from one address to another. Nobody really owns Bitcoin. Bitcoin, what happens is when a miner successfully creates a block, they receive a certain set of Bitcoin. That's when Bitcoin is created. And then every single transaction for those Bitcoins is validated by just simply looking at where that miner sent the Bitcoins to. So for example, if miner sent that Bitcoin from point A to point B, it'll validate that. And then the same Bitcoin will be sent from point B to point C, and it'll validate that. So all we're really validating is the route that the Bitcoin took to get up to the latest block. And so what this Merkle tree, what this full node will do is it'll validate this route. It'll say, this Bitcoin has successfully come from the miner through all of these people to this person. I accept that, and it's a part of my immutable blockchain ledger. The full node will keep it. And so the Merkle root of the tree that miner holds for all of the transactions will be this few kilobyte long string that is immutable, that will always exist, and that will always represent the transactions that full node has accepted. Now, if I, as a wallet, want to see if that blockchain, if that block header and those transactions are valid, all I have to do is I'll have to download the block header, I'll have to hash it, and then I have to see if the hash matches what the full node propagated. And the hash will include the root of the Merkle tree. So the Merkle tree is bundled up into the block header. And so as long as the hash is the same as what the full node has propagated, we're good to go. All I have to do is conduct a single SHA-256 hash function, see if the output matches what the full node is outputting, and then we're good to go. And so as a light wallet, I really don't even need to download any transactions within that block itself. I just have to look at the Merkle root and then the block header itself, which is only 80 kilobytes large.
All right. We have properly set the table at this point. Let's talk about proof of work and proof of stake. So the system that we've described is proof of work. Miners validate transactions by solving cryptographic puzzles associated with a set of transactions, and those set of transactions turn into blocks that are verified. Proof of stake is quite different. It replaces this system, which is energy intensive because these miners are doing these repeated calculations to attempt to solve cryptographic puzzles, And by the way, they're all doing similar cryptographic calculations in parallel, and only one of them is going to solve a block. So there's a whole lot of wasted work that's essentially going on. I mean, it's not actually wasted because we don't know a better way of doing this. Maybe proof of stake is a better way of doing this, but we know that proof of work works, even though it takes a ton of energy. It's just the only way that we know works right now that at least has been implemented. Proof of stake is different. Explain what proof of stake is.
Absolutely. So again, at a very high level, proof of stake is essentially a group of individuals who have an amount of cryptocurrency. So for example, they have some level of Ethereum in their possession. And what they do is they stake that Ethereum onto the blockchain, and they say, here is X number of Ethereum. Block this up in the blockchain. I'm not allowed to use it. But what this Ethereum represents is my ability to have a vote on the validation of a block. And so what the network will do is it'll look at everybody who staked some level of their cryptocurrency, and they'll say deterministically and using a probability function, what it'll do is it'll select an individual who has staked their cryptocurrency. It'll hand them the blocks on the network or the transactions on the network waiting to be confirmed. And it'll say, here, validate this block. Just do it. And it'll wait for that person to validate the block. And this person will then propagate this block to others once it has been validated. And the reason why this is considered to be secure is that this individual has staked some considerable amount of their own cryptocurrency. And so in doing so, they're essentially trusted to validate this block in a way that other nodes will accept as truthful. If they fail to validate this block in a way that other nodes accept to be as truthful, and instead they do so maliciously, the cryptocurrency that they have staked is lost. All other truthful nodes will essentially deem this malicious actor's block as invalid, and it will deem their cryptocurrency that they have staked as gone. It'll vanish. And so they're out of whatever they staked. And so what the system does is it introduces a completely new paradigm when it comes to potentially validating and securing the blockchain.
Software Engineering Daily is brought to you by Consensus. Do you think blockchain technology is only used for cryptocurrency? Think again. Consensus develops tools and infrastructure to enable a decentralized future built on Ethereum, the most advanced blockchain development platform. Consensus has hundreds of Web3 developers that are building decentralized applications, focusing on world-changing ideas like creating a system for self-sovereign identity, managing supply chains, developing a more efficient electricity provider, and much more. So, listeners, why continue to build the internet of today when you can build the internet of the future on the blockchain? Consensus is actively hiring talented software developers to help build the decentralized web. Learn more about Consensus projects and open source jobs at consensus.net/sedaily. That's CONSENSYS.net/SEdaily. Consensus.net/SEdaily. Thanks again, Consensus. So if you think about Twitter, on Twitter, the people who have a blue check mark next to their name, they have been, quote, verified. Whatever that means, they have been verified. In some sense, that's similar to the fact that to the idea of proof of stake, because these people have gotten verified because they have either a public identity that is important elsewhere, and they're not going to taint that public identity by publishing false or cruel information on Twitter, or perhaps they've been on Twitter for so long, they have a massive following, and they've got a bunch of fake accounts that are trying to impersonate them. So, they've got a blue check mark, and they're going to be unlikely to do something that would make them an unverified user, because if they lost that blue check mark, they would be subject to all kinds of masquerading attacks and so on. So the idea is that the people who receive the blue check mark on Twitter are generally people who have an incentive to maintain and in fact improve the quality or the worth of that blue check mark. And it will be a self-regulating system, because sometimes people who have a blue check mark and engage in malicious behavior, they have a bigger spotlight on them, so they get kicked off the network more aggressively, or they can lose their blue check mark, I believe, under some circumstances. And similarly, in proof of stake, you've got this pool of validators who have been chosen by the network as validators who are, the network is important to them. So they have a stake in the network. They've got a lot of Bitcoin, or they've just been validating transactions for a long time, perhaps. And I would love to get into how validators are chosen. But not only that, if they do something wrong, if they try to validate, if they are chosen by the network to validate a set of transactions as being valid or invalid, and there's an invalid transaction, and they make a mistake, then if the network detects that later on, that they've made a mistake, the network is going to subtract all of the Bitcoin that they own, so that the stakes are pretty high to be truthful in your validation. Is that an accurate picture I have painted?
Absolutely, yeah. So the Twitter analogy is actually a very good one. The only thing I would say about that is I don't know how much value people would see, in having that blue check mark. I'm sure many individuals would, but at the same time, many individuals, if they happen to lose that check mark, I don't know how much, how much of an impact that would have on them. However, with proof of stake, what you're staking is your money. You're staking savings. You're staking something that has, quite literally a financial impact. And so there's a lot more incentive for you to do very little wrongdoing here. And yeah, everything else you've said is quite correct. You stake cryptocurrency. Bitcoin, in my opinion, I don't see it moving to proof of stake anytime soon. But Ethereum, for example, would be a good example. If people were to stake Ethereum, they stake their Ethereum, and proportional to their stake, a probability is assigned to them being chosen to validate the next block. And so it would be in their very best interest to validate it correctly. Exactly.
How do people end up in the validator pool who can be randomly selected to validate these transactions?
So all you really have to do is stake some level of Ethereum. So right now, the biggest proof of stake prototype and test of concept is happening on the Ethereum network. Hasn't been published there yet, but it is being tested, and Ethereum will most likely move to a proof of stake system within the near future. And so all an individual really has to do is conduct a transaction saying, I have X amount of Ethereum, lock this up, and consider me a validator. And as long as they have that Ethereum, they will be, in a very decentralized and trustless aspect, they will be considered as a part of the validating pool, as a potential person to be selected. The more cryptocurrencies you stake, the higher probability you have of being selected. This is because you have a higher stake to lose. Why not give you a chance and see if you can validate it properly?
And the important part of this is that if you validate a transaction that we later find out is incorrect, two things need to happen. First of all, we need to take all your cryptocurrency that you've staked and grab it from you. But two, we also need to roll back the blockchain somehow and undo that transaction. So what is the process of validating the validators?
That's a good question. I'm not too familiar with the intricacies of proof of stake itself when it comes to rolling back and punishing validators. That's something I will be researching in the future. Right now, I'm focusing a little bit more on proof of work.
We'll be doing several more shows on this topic. I think I already have a show about Casper scheduled, so I'm sure we can go a little bit deeper in that episode.
Absolutely, yeah. I'm actually in the process of reading the Casper white paper right now, which is why I'm not entirely versed in how punishing of validators happen.
Totally fine. What's that experience been like? But by the way, how do you attack these white papers? Some of these are pretty dense.
They are. Time, honestly. All you really need is time. Again, starting from a very fundamental level really helps. For example, I tried diving into how Ethereum worked before I learned how Bitcoin worked. Did not happen. So I went back to square one. I read the Bitcoin white paper. There's an incredible amount of resources out there that are based around learning Bitcoin. I read a fair amount of them. And that's where I really started to feel confident about being able to learn other concepts, such as how the Ethereum network works, concepts such as how the Lightning network works, and again, concepts such as proof of work and how Casper will be working in the future. And so again, just starting from the fundamentals and working your way up from there will save you time down the road when you're trying to get into more complex topics in the field.
It's so true. And I'm laughing because I think it was the second or third week of shows on Software Engineering Daily that I did shows on Bitcoin and Ethereum, mind you, without really understanding how this stuff works. And it was just a train wreck. Like I tried to do a show on Lightning networks, And I had some good questions to ask, but mostly I had no idea what the questions I was asking meant. I just knew that they were questions that other people were asking, which is just not a recipe for walking away with a good understanding. So yes, I think we rehashed this several times in the introductory questions, but always better to start with the fundamentals.
Absolutely, yeah.
So a little bit more about proof of stake. So in some sense, this leads to a rich get richer problem because the people who have the money to stake can earn interest on that money. So is this a rich get richer problem? Is that leading to further centralization? Is that problematic?
Absolutely, yeah. So that's something I've definitely been considering and looking into. Proof of stake works to solve a lot of the issues that proof of work has. The expenditure of an insane amount of electricity, the potential centralization risk, making the 51% attack a little harder because there's no mining at work. All you're really doing is randomly selecting people to validate the network. But you're right. There is this risk of the rich get richer, potentially when it comes to proof of stake. And the argument could be made that those who stake a large portion of their wealth in order to secure the network deserve to make that money, deserve to reap the benefits of it. And that same argument has been made about the small number of wallets that hold a large number of Bitcoin. Maybe the early adopters of Bitcoin deserve to hold and reap the majority of the benefits of the network because they took such a massive risk early on. I personally wouldn't agree with that mentality because, again, the point of decentralization, trustlessness, and censor-resistant currencies is to put the damper on corruption, to reduce the level of corruption and centralization and the corruption and the abuse of power that comes from centralization. And so although that argument that can be made, the fact that people who take a greater risk early on or who stake a lot of the currency should reap benefits down the road, there is always the possibility that power and a large amount of control over any system will corrupt any individual, right? That may, and that will probably will happen if centralization again becomes a theme in cryptocurrencies. And so, yeah, that is a very real risk when it comes to proof of stake, in my opinion. Again, I have to do a lot more research on this field and see perhaps there is a way to tackle this. But yes, the rich getting richer is a problem. However, it is important to note that when you're considering the probability of somebody staking 10,000 Ethereum versus 8,000 Ethereum versus 7,000 Ethereum versus 5,000 Ethereum, you're probably going to have a relatively negligible risk of the rich get richer / centralization problem. When you consider like the extremes of this, what a lot of people think is the probability of somebody staking 10 Ethereum versus 1 Ethereum. The person staking 10 Ethereum is definitely going to have a much higher probability of being selected and then a much higher probability of earning more Ethereum, and so the rich get richer. But when you consider a fleshed out system, or relatively fleshed out system like Ethereum, you have a lot more decentralization, a lot more distribution of the current currency, and there will be a lot more competition when it comes to staking their currency through proof of work. So there is definitely a real probability of the rich get richer problem being negligible, but that again remains to be seen. And for me, myself personally, research has to be conducted before I can make a definitive conclusion about that.
Well, and the other aspect of that is like, if you want to stake so much Ethereum or so much Ether that you're just going to dominate in the rate of being selected to validate blocks, you're probably going to be staking so much Ether that your funds would be better spent elsewhere. Like, it would just make more sense for you to allocate them into index funds or something else, because this is essentially like a bond, like it's an interest-bearing instrument with a pretty predictable interest rate. And if you just say, I want to dominate and always get that small amount of interest, you might have to make a very irrational bet if you really wanted to dominate it that bad. And it doesn't have the same problem of being subject to a 51% attack because anybody can always check your work. And if they prove that you're doing something wrong, then you just lose all of that money. And it's just like, I don't know, it seems like a very sensible solution to me.
Yeah, so what you mentioned is actually a valid point, and it's actually a fundamental aspect of the game theory that exists not just behind proof of stake, but as well as proof of work. So if you look at 51% attacks in Bitcoin, if you're a miner and you have 50% of the hashing power in the network, it would probably still be in your best interest to keep mining and not double spend your coins if you happen to have the majority of hash power. Because if you do that, you will get caught and you will be propagated off the network. And so you will not be able to make any more mining profits. That's a very valid point, that a lot of people will act rationally. And again, with proof of stake, the exact same mentality comes to play. If you have 30 or 40% of the network staked using your own currency, it would probably be in your best interest to act truthfully to better your holdings.
The other issue at hand, and this is somewhat tangential, is that one of the problems of proof of work is proof of work leads to hardware centralization in a very physical manifestation, which is problematic. Okay, proof of work functions today, like that's great. But what happens when government currencies start to not look so appealing for any use case? Like that is a potential outcome. And when that happens, if there is a hardware centralization, that's a centralization that is existent in the physical world. And governments are pretty good at administering control over physical assets and disrupting physical assets. And proof of stake, in contrast, seems like a more ephemeral consensus mechanism that would not be centralized in any particular hardware dimension.
Absolutely. So the technical beauty of proof of work is that if you happen to restrict, for example, the sales of ASIC mining hardware, which is what's used for the majority of Bitcoin mining today, the difficulty of the network will go down and individuals will be able to mine Bitcoin let's say at a very extreme level with their GPUs again. And so that level of technical decentralization and the level of access will still be available to individuals despite this restriction of hardware. The difficulty of Bitcoin scales with the level of hash power that the network has. And so the reason why proof of work is determined to be effectively secure. If somebody wanted to launch a 51% attack on the Bitcoin network, they would have to spend, I think, upwards of millions or potentially even billions of dollars in order to purchase enough hardware and expend enough electricity to make that happen. And so that's really where proof of work is expected to be relatively secure, despite the fact that, like you said, there is dependency on hardware and hardware can be restricted. The difficulty adjustments that happen on the Bitcoin network will stem to prevent any extreme level of attack by the government or otherwise. But again, like you said, there is an inherent disadvantage to relying on hardware, and that is potential restrictions in the short term that may happen, and as well as the overlooming environmental impact that comes from such expanded hardware usage. And so proof of stake is valuable in that sense. But at the moment, this rich get richer problem, and as well as the fact that nobody has really been able to successfully implement it and ensure that it's attack resistant yet, is a very important aspect that shouldn't be neglected. The reason why Bitcoin can be deemed as secure is because it has existed for 10 years with proof of work, and like you said, it works. And the network has not been able to be attacked, and that's proven. You put something out there and you let it be attacked, and if you can see that it's resistant, there is some great inherent value in that. And if hopefully proof of stake gets to that point, we can say, yeah, proof of stake works. It's a better alternative. But until then, it's a very fine line to teeter across when trying to talk about the long-term effective nature of proof of stake.
One thing I think that is ironic about these systems, like we call it proof of work or proof of stake, and they're proof-based systems. Like you can prove that you have done the work to validate some transactions by presenting the solution to a cryptographic puzzle. And you can similarly prove that you have a stake in the network by giving some ether. But what I think is funny is that the only way that we know that these systems work is if we actually deploy them and then test them and have empirical data to show that they work over time and that nobody has found a vulnerability in them, which is not at all what a proof is in fundamental computer science terms.
Yeah.
So I just find it hilarious.
Yeah, so that's honestly when Bitcoin, if you go all the way back to 2009 and you look at Satoshi Nakamoto's old email lists, and he was a skeptic himself. He was like, hey, I don't really know if this is going to work. Just try it out, right? People just started throwing things at it. People built on it. Nobody really knew if it was going to be secure or if it worked. Attacks, happened. They were attempted. It continued to resist and become more resilient. And it's essentially evolved into what we have today, which is something that we know works. And like you said, it is, if you think about it, it's ridiculous. How can you expect the system to be secure when you just let it live and you see what happens to it? And I agree with that, absolutely. But that's really why when you look at something like Bitcoin, for example, I can't question its immutability and its security, because all of that has happened and we're at this point today where nothing has changed about it. And so we can effectively trust that the system works.
Although, equally hilarious when you talk to economic traditionalists and they are just looking for an excuse to dismiss cryptocurrencies, and they hear about the deflationary argument. Oh, Bitcoin is deflationary. We've seen what happens with deflationary currencies. People just don't spend them. And therefore, because people don't spend them and we know that they just increase in value over time, this will not work as a currency. Therefore, I can ignore this space entirely and dismiss everything else that you're saying to me, when in fact, as far as I know from these conversations, maybe there are more data points on this, but the main data point has something to do with Japan. Like Japan had a deflationary currency for a while, and that was catastrophic. And maybe there are some other examples, but I don't know. I guess I'm talking with a little too much conviction here, but it just seems like we just don't have much data in terms of testing different economic systems. We just really don't have a whole lot of data. So anybody that says, we really know this, we are so sure of this thing about economic systems, that's another, talk about skepticism. I'm pretty skeptical of people who are so economically sure of something like that.
Absolutely. So again, people who are skeptical of the impact of Bitcoin potentially being deflationary, I give them credit. You should be skeptical. Should you dismiss Bitcoin, its technology, and its impact because you're absolutely sure that it will cause a deflationary spiral and destroy the economy? That I'm sure we're on the same page. I disagree with that kind of mentality. There is something to be considered when it comes to Bitcoin. It has a limited supply, it's immutable, and its inflation right now is controlled in every sense of the way. And there's value in that, but at the same time, there are economic impacts that remain to be seen when it comes to widespread adoption of Bitcoin. And we don't have enough data, you're right. We will see what happens, but I personally don't feel like any level of adoption of Bitcoin would be a bad thing for the economy. I personally feel like inflationary currencies will continue to exist, but there's something to be said about Bitcoin being used as an inherent store of value that will continue to grow and be immutable in the future.
Right. Yeah, maybe a deflationary store of value is great. Maybe it's not so useful as a currency.
Absolutely. You're right. And again, everybody should be doing their own research about the economic impacts of Bitcoin itself. And for me, that's also one of the great appeals of Bitcoin. I'm studying business as well, and I'm taking a minor in economics. And this is a very basic economic concept: deflationary spirals versus the impact of inflationary economic incentives. And so seeing how Bitcoin not only has impact in the world of technology, but as well as an impact in the world of economics and the way we use currencies and grow our economies itself, is something that's very, very, very intriguing. And if you're interested in seeing how the world may change because of this technology, the economic aspects of Bitcoin should absolutely be studied rigorously. That's something I've been doing and I hope to do in the future as well.
Let me ask you another technical question about proof of stake. Does proof of stake improve scalability? Because I understand that it alleviates the electricity demands, but I imagine if you can have this network where you've got these validators and you can just say, okay, we've got this pool of transactions, we can actually do things in parallel now because we can just take different sets of validators and throw disjoint sets of transactions at them, and we can get a whole lot more transactions validated in the same amount of time rather than redundant proof of work systems. Is that accurate? Is proof of stake more scalable? Does it add to scalability?
Absolutely, yeah. So that's actually a very interesting topic to consider. The reason why a lot of the restrictions exist in the Bitcoin network are because of the proof of work algorithm. For example, Currently, the block size is approximately 1 megabytes with SegWit up to 4, relatively small. One of the reasons why that is because miners are expected to mine a block within 10 minutes. And then this new block that they mine is expected to be propagated across the network as soon as they mine it. And it's expected to propagate relatively quickly because miners then have to spend up to 10 minutes mining the next block. And so a considerable level of time is expected to be expended mining every single block. And so proof of stake, what that effectively does is it eliminates that kind of time constraint. It eliminates that expected expenditure of time. And very hypothetical terms, the validation of a block is almost instant. And so what that means and the implications that has is that you're able to propagate blocks at a much faster level. And while potentially reducing the level of orphan chains, what that means is that chains that get left behind because the blocks got propagated too quickly. And so you're right. If the validation of a block is almost instant, then blocks can potentially hold many more transactions. A lot more protocol changes that can come into play because block propagation and block time restrictions are not as big of a part of the equation anymore.
All right, Subhan, it's really been great talking to you, and I could continue talking to you for a long time, but I know we're up against time. Yeah, I guess, one other question. So, you're looking at computer science and business at the same time. I know you're not going to start a business anytime soon, probably, or maybe you are thinking about it, but you got some ideas?
Yeah, well, I have some inspiration. I'm working for a company called Fix in Toronto right now. The CPO is 23, the CTO is 24, and the CEO is 27. And these guys are tempting me. I might drop out and start a business. You never know. Could happen. But yeah, go ahead.
you got any ideas yet, or nothing you can talk about publicly?
Yeah, nothing I really want to delve into yet, but we'll see.
Okay. All right. Well, we can do another show in the future.
Absolutely.
Subhan, thanks for coming on Software Engineering Daily. It's been great talking to you.
Absolutely. Great talking to you as well, Jeff. Thank you very much for everything.
If you are building a product for software engineers or you are hiring software engineers, Software Engineering Daily is accepting sponsorships for 2018. Send me an email, jeff@softwareengineeringdaily.com if you're interested. With 23,000 people listening Monday through Friday and the content being fairly selective for a technical listener, Software Engineering Daily is a great way to reach top engineers. And I know that the listeners of Software Engineering Daily are great engineers because I talk to them all the time. I hear from CTOs, CEOs, directors of engineering who listen to the show regularly. I also hear about many newer, hungry software engineers who are looking to level up quickly and prove themselves. And to find out more about sponsoring the show, you can send me an email or tell your marketing director to send me an email, jeff@softwareengineeringdaily.com. And if you're a listener to the show, thank you so much for supporting it through your audienceship. That is quite enough, but if you're interested in taking your support of the show to the next level, then look at sponsoring the show through your company. So send me an email, jeff@softwareengineeringdaily.com. Thank you.
Wow.